Sandwich panelling, also referred to as composite panel, insulated panel, or ACP, which stands for aluminium composite panel, have been in the news more and more in recent times. Most recently with a fire in a high-rise apartment block here in Melbourne. And who can forget the tragedy of the Grenfell Tower in London? Now, while these losses could certainly have been avoided, the light that has come out of these events is that public awareness around these products is at an all-time high. What concerns us, however, is that building codes seem completely unable to keep up with the wave after wave of new products hitting the market. One area that I fear we are overlooking is just the number of domestic properties that are being constructed out of these same materials, particularly second floor extensions. I was lucky enough to grab some time with Dr. Mark Tatam of Kingspan Insulated Panels, who is an expert in this field, to understand more about the products that are out there, which ones we should be looking out for, and just as importantly, which ones we should be using and or recommending to our customers. Enjoy.
I'm Mark Tatam. I'm the Building Technology Director for Kingspan Insulated Panels in Australia. We're part of the Kingspan Building Products global group of companies, and there's a number of divisions in Australia, including insulated panels, insulation, environmental and access floors. Insulated panels is the largest of those. We aim to provide to the market building solutions, all-in-one solutions and sustainable product development, most notably in the areas of fire and thermal performance. There's a range of insulated panels and insulation products on the market today. The most common ones are polystyrene, polyurethane, polyisocyanurate and mineral wool products, but also there's some polyethylene type materials as well. Some of them are worse performance in fire than others, and it's unfortunate that there's been a number of fires with some of these products. In terms of performance, generally speaking, historically polystyrene has been a poor performer as per data in cool rooms over the years. Polyethylene is also a high-risk product, but then you start to look at better performance in products through polyurethane, polyisocyanurate or PIR and mineral wool products. Kingspan make a number of PIR products, which is all factory mutual certified for insurance, large-scale fire tests. We also supply mineral wool to the market in applications which are more demanding in terms of fire performance, where non-combustibility, for example, might be an issue. However, mineral wool products are generally more expensive and have disadvantages in other areas. So the PIR which we make is an overall good performer in fire, spanning, aesthetics and long life and high thermal performance. We don't make polystyrene or polyethylene based products because they're generally down at the low end of the fire performance range, and we pride ourselves on providing safe building products to the marketplace. Building regulations require performance in a number of areas, and the products that were typically used, say 20 years ago, are not quite up to the mark in terms of where they need to be in terms of building regulations. So there's a lot of building products out there that try to meet a number of building regulations all at once in terms of performance solutions. So for example, you try and meet fire performance and thermal performance and weather tightness and aesthetics. So rather than have one separate product for each of those, you try and have composite products that try and meet all of those things. So there's a number of insulation and insulated panel products in the market that try and meet those requirements in varying levels of success, some better than others. Insulator panels started out in refrigerated trucks and cool rooms and still used in those applications, but because of the advantages it has in many areas, it spread to all sorts of applications in way past cool rooms, residential, commercial, hospitals, swimming centres, data centres, and residential housing, both high-rise and low-rise single unit accommodation. So the growing use of polystyrene is a concern in those areas, as it still is in the cool room industry. In recent times, we've seen issues with facade fires, and that's a result of products that are not quite suitable for the application that they're going into, and as well as building regulations not keeping up the pace with changes in the market in terms of selection of products. In terms of multi-residential and residential housing, there's been a growing cause of concern with the use of polystyrene products, and that has been difficult. Product testing is usually done through small-scale tests to meet building code regulations. That's more for cost effectiveness and simplicity, so product manufacturers can develop their products and get them into the marketplace in a reasonable amount of time. Unfortunately, the market has become more complex, and the way products are used in building applications has become more complex, so very difficult to monitor that situation. The fire tests don't exactly replicate real life conditions, so you have the problem where something might perform well in a small scale test and could perform very poorly in a large-scale test. Typical in the building industry is that the lack of data in terms of how much polystyrene is actually out there in residential applications, because each project is a small house or multi-residential application. It's very difficult to track the extent of the problem and therefore assess the risk. So we're only starting to come to grips with that now. Insulation and insulator panels can perform very differently in fire, even between products of the same sort. So they all have varying degrees of combustibility. Mineral wool products can get to the level of non-combustible, but the other products are all in a combustible bucket, if you like, with varying degrees of performance. So one of the issues we have is it's not so much the product, it's the product in the application. So if you put a high-risk product in a high-risk application, then you obviously have a very big problem and a potential for loss. So, for example, you put a polystyrene into a high-risk application, that would be the worst result, especially if it was exposed material. And one of the issues with fire is it depends on how products are installed and not just the products. So you can have products well installed, but you can have products poorly installed. So if you're looking at insulation or even insulator panels, you have cut edges and sides which are open and the core is exposed, and then you have service conduits for whether it be for plumbing, electrical or something like that, where you're cutting holes in the material. So there's a degree of exposure of the product which is very difficult to measure and certainly not related to small-scale fire tests. So at the end of the day, you can have high-risk applications and low-risk applications. What you don't want to be doing is putting high-risk products into high-risk applications. But since it's very difficult to control the high-risk applications, it's always better, certainly in hindsight, to use better products to start with. Because of the composite nature of panels in recent times, and products like rendered polystyrene, for example, or insulated panels, it's very difficult to identify what the material is from the outside. So it could be a low risk or it could be a high risk. And in terms of trying to address this, the market's decided that When there's some doubt about the products in an application, then sampling on site is required, where someone will come in and take a sample of material and then take that away and try and identify the product, and if necessary do tests on that to assess what the fire risk might be. Products can sometimes perform well in small scale tests or can be configured to perform well in small scale tests, but can actually perform very badly in real life applications. One of the problems is the way products are tested. They never replicate real life performance. So that's one reason why you would like to do large scale testing. In fact, some of the insurer-approved tests are large scale. Having said that, if we're basing product selection for the building code on small scale tests, then we need to control the way that they're used better than we are at the moment in terms of where they're used and other issues in the marketplace. Problems we have at the moment is product substitution and not enough diligence in terms of who's responsible for product building and design in the marketplace, which lends to the use of more cost-efficient products at the expense of performance. So you're reducing the risk, but saving money in construction, which is not a good outcome. Fire spread in real life is not just a function of the combustibility of the material, whether it's the insulation or the panels or whatever that's used, but it's also a function of the amount of which the product's exposed, whether it's open to air and oxygen, and how close and severe the fire source is. This is why risk is usually evaluated on a holistic basis in terms of a whole building approach, because it's very difficult to determine just from small scale tests what the true level of risk is. So buildings that are in doubt need to have some sort of inspection to assess the overall risk. And as part of that risk, then the materials that are used in the construction should be evaluated and also assessed in terms of exposure and proximity to fire sources, etc., etc. So if you're interested in finding more about Kingspan Insulated Panels, then contact us on www.kingspanpanels.com.au, and we've got plenty of information and advice, including a technical help desk which can answer any of your inquiries.